Think about the last time you tried to run a large language model on your own computer. You probably hit a wall. The memory requirements were too high. The processing power was insufficient. For years, the promise of artificial intelligence has been tied to massive data centers and expensive cloud subscriptions. You send your data out, you wait for the response, and you pay a monthly fee for the privilege of using the technology. That model is changing. We are seeing a shift where the heavy lifting happens locally. The barrier to entry is dropping. Here is the thing. We are talking about frontier-level performance now. Not just basic chatbots, but models that can reason, code, and analyze complex data. The latest developments suggest that a new architecture is making this possible without requiring a cluster of graphics cards. We are looking at a scenario where a single consumer-grade GPU can handle workloads that previously demanded enterprise hardware. This is the core of the efficiency revolution we are witnessing. To understand the magnitude of this shift, we need to look at the specific numbers. The new iteration, often referred to as Gemma 4, utilizes aggressive quantization techniques. Specifically, we are talking about 4-bit precision. This means the model weights are compressed significantly without losing the critical intelligence required for high-quality output. The result is a system that can operate with as little as 6 gigabytes of random access memory. That is a drastic reduction from the requirements of previous generations. Now consider the competition. We have Llama 321 and Mistral. These are powerful open-source models that have dominated the landscape for the past year. When we compare them against this new Gemma architecture, the differences become clear. In terms of raw inference throughput, the Gemma implementation shows a marked improvement in tokens per second. This is the speed at which the model generates text. For a user, this translates to a more fluid conversation, less waiting, and a more responsive experience. However, speed is only half the equation. VRAM efficiency is the other critical metric. Video random access memory is the bottleneck for most local deployments. When you load a model, it sits in the GPU memory. If the model is too large, the system has to swap data to your main system memory, which is much slower. This causes stuttering and lag. The Gemma architecture optimizes how data is stored and accessed. It allows the model to fit comfortably on a single card. This eliminates the need for multi-GPU setups. You do not need to buy 2 or 3 graphics cards to run a frontier model anymore. This brings us to the sweet spot for deployment. The industry has been pushing towards multi-GPU clusters for a long time. That approach works for companies with deep pockets. But for independent developers and smaller teams, that is not viable. The single GPU sweet spot changes the economics. It allows for self-hosted inference via specialized libraries. These tools democratize access to large-scale models. You do not need a supercomputer. You need a single machine. But there are challenges. We cannot ignore the stability issues that have appeared in early adoption phases. When we look at mobile edge devices, such as the latest Pixel phones, the GPU acceleration shows signs of instability. This indicates that while the architecture is efficient, the software ecosystem is still maturing. Heterogeneous computing environments are complex. The model needs to balance between the central processor and the graphics processor. Right now, there is still work to be done to ensure that the experience is rock solid across all hardware configurations. Despite these challenges, the implications are profound. The release marks a strategic shift from API-dependent cloud models to fully local, open-weight deployment. This eliminates subscription costs. It also addresses data privacy concerns. When your data stays on your device, it does not leave your control. You are not sending your personal documents to a third-party server for processing. This is a significant change for anyone concerned with security. We also need to consider the financial aspect. Training frontier models is incredibly expensive. Estimates suggest costs in the tens of millions of dollars for the largest systems. This creates a barrier to entry that limits who can build AI. By optimizing for inference on consumer hardware, we are decoupling the capability of the model from the cost of the infrastructure. This suggests a future where frontier capabilities are not tied to massive training facilities. It accelerates the proliferation of AI agents and tools in resource-constrained settings. Let's talk about the latency. Token generation latency is the delay between you asking a question and the model starting to answer. In the Gemma 4 configuration, this latency is optimized through the same quantization strategies. The model does not need to load the entire weight set into memory at once in the traditional sense. It manages the data flow more efficiently. This reduces the initial wait time. It makes the interaction feel more natural. Comparing this to the older Gemma models, the 2B and 7B parameter versions were already efficient. But the jump to this new iteration represents a qualitative change. It is not just about size, it is about the architecture itself. The research indicates that the underlying technology from the Gemini family is being leveraged to improve efficiency. This means the intelligence is retained while the footprint is reduced. For those of you thinking about deploying these models, the ecosystem is evolving rapidly. Specialized libraries are supporting self-hosted inference. This means you can run these models on your own server or even a powerful laptop. You are not reliant on a cloud provider. You have control over the environment. This is the democratization of AI. It is moving from a service you rent to a tool you own. However, the stability challenges on mobile devices remind us that we are not at the finish line. The optimization in heterogeneous computing environments needs further work. We are seeing the early stages of this technology. The promise is there, but the polish is still coming. Developers need to focus on making these systems robust across different hardware. In conclusion, we are standing at a pivot point in artificial intelligence. The trend is clear. We are moving away from the idea that you need massive infrastructure to access advanced capabilities. The single GPU frontier is becoming a reality. The efficiency gains in VRAM and throughput are enabling high-end AI on consumer hardware. This shift has financial and privacy implications that go beyond just technology. It changes who can build AI and how it is used. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.